Hi and welcome. This video is the third part of a video series on C# generics. This video is also part of a tutorial which is the fifth part of a course on advanced C# concepts. In this video, we'll look at generic delegates and events in C#. We'll also look at other concepts associated with C# generics, including the use of a generic C# built-in data structure, namely the queue data structure. We'll explore these concepts associated with generics through a practical example. The theme I've chosen for this practical example is a warehouse management system. For more videos on advanced C# concepts and much more, please consider subscribing, and please ring the bell so that you'll be notified of future content released from this channel. We need to use our imaginations a bit because the example will be highly simplified and expressed through a .NET Core console application. So the code will provide the functionality of a real-time monitoring system for items entering a warehouse and subsequently being processed. By processed, I mean the item is placed in a predefined location within the warehouse for storage. So an event is raised when an item enters the warehouse, and an event is subsequently raised once the relevant item has reached its predefined location within the warehouse. Note that when I refer to an item, I'm referring to a batch of units of a particular type. So in our example, the item can refer to a quantity of units. A unit in this example will be a hardware-related item. For example, a drill, hammer, ladder, etc. So if we use our imaginations, we can picture this scenario in the real world. An item enters the warehouse and is scanned. So let's say the item has a QR code attached to it that when scanned provides necessary information about the item. When the item is scanned, an event is raised. So for example, a supervisor could be monitoring the relevant activities relating to the warehouse, and when an event is raised, the relevant information is displayed on a screen in real time. So the supervisor could, for example, be monitoring these real-time events using a handheld device, a desktop computer or a notebook computer. The display could perhaps be a large screen TV that multiple employees can monitor. The use of events decouples the component that raises the event, which could, for example, be an on-site scanning facility, from the component that receives the event notification, which could, for example, be a handheld device used by a supervisor to monitor events either on-site or even remotely if required. So, for example, a box containing drills arrives to be stored at the warehouse. The QR code attached to the relevant box that the drills are in is scanned. The box is then transported to a predefined location in the warehouse to be stored. So when the box is placed in its relevant location, perhaps pressure pads at the location are used to detect that the box of drills has been processed. When I say processed, I mean has arrived at its designated location to be stored in the warehouse. So when the relevant pressure pad detects that the relevant box has been placed in its designated location in the warehouse, an event is raised. And the relevant information about the event is sent to the calling code, which will then display the relevant information about the event and the processed item to the supervisor's screen. So this is a real-time monitoring system for a warehouse. Please note, I've never actually worked in a warehouse, and this example is purely from my imagination. It's obviously always best when building a particular kind of application or system to consult with someone with the relevant domain knowledge. This example only serves to help with the understanding of generic delegates and events. Right, let's begin. Let's create a .NET Core console application and let's name this project Hardware Warehouse Management System. So this project will contain our calling client code. We want this project to reference another component responsible for generic functionality associated with a warehouse. So let's add a .NET Standard Library project, and let's name this project Warehouse Management System API. Let's create a reference to the Warehouse Management System API project from the Hardware Warehouse Management System project. So we'll start by building the generic functionality for our Hardware Warehouse Management System by adding code to our Warehouse Management System API project. So we have separated concerns here. We have created two components, one to handle the specific functionality of the hardware warehouse. This functionality will be encapsulated in the Hardware Warehouse Management System project. The code in this component will focus on displaying the status and data about specific hardware-related items to a screen in real time as certain events are raised. The other component is a generic component specifically created for handling the management of any warehouse. This component is responsible for raising events associated with any warehouse to the calling client code. When each event is raised from the Warehouse Management System API component to the Hardware Warehouse Management System component, the relevant data associated with the relevant event and item is displayed to the screen in real time to, for example, a supervisor. So let's write the code for our example. Let's start by deleting the default class from our Warehouse Management System API project. Let's add a class named Custom Queue. In the Custom Queue class, we are going to wrap the functionality provided by the built-in C# generic queue data structure. We are going to customize the functionality of the queue by adding two events. Simply put, one event will be raised when an item is added to the queue. The other event will be raised when an item is removed from the queue. As you may have guessed, when an item is added to the queue, this denotes an item, for example, a box containing drills, entering the warehouse. The second event denotes the event that will be raised, for example, once the relevant box containing the drills has been processed, i.e., has been placed in its specified location to be stored within the warehouse. So let's make our custom queue class a generic class. A generic class can contain more than one type parameter, but we are only going to add one type parameter for this class. So using the capital T is the generally accepted way to represent the placeholder for a type parameter in a generic type definition. If there were two type parameters, we could add a comma and then the capital letter U to represent a second type parameter. This generic class will only contain one type parameter, so let's remove the second type parameter. So by adding T within angle brackets following our class's name, we have created our custom queue class as a generic class. So let's create a private member variable of the inbuilt C# queue generic collection type. So let's define this member variable as the generic queue data type, and let's name our variable _queue. And you can see that a directive at the top of our code already exists to the system.collections.generic namespace. The queue data type is a member of the system.collections.generic namespace. Let's create a parameterless constructor for the custom queue class. Let's instantiate the _queue variable within our constructor. Let's create a read-only property and implement code that returns the number of items currently stored in the _queue collection. Let's create the definitions for the public methods that will be included in the custom queue class. We'll first add their definitions and then implement the code for each method. Let's create a method named addItem that contains a parameter of type T. This method will be called when an item is added to the custom queue. Let's create a method named getItem. This method will return an item stored within the queue to the calling code. This method returns a value of type T and contains no parameters. Let's create a protected virtual method named onQueueChanged. This method will encapsulate the functionality for raising the events of this class. It contains a parameter of a user-defined type that we need to create. The value passed to this parameter will store information about the relevant event being raised from within this method. So let's create a class definition for a class named queueVentArgs. This class will extend the functionality of the system.eventArgs built-in class, so let's write code so that this class inherits from the system.eventArgs built-in class. Let's add a read-write auto-implemented property named message to the queueVentArgs class. The message property will return a string narrative which will include details about the item to which the event pertains, as well as information about the event itself. So the last method we need to create is a public method named getEnumerator. So this method returns a value of the generic Enumerator interface type to the calling code. So let's implement the code for this method. The implementation is one line of code which returns the value returned from the _q member variable's getEnumerator method. By implementing this getEnumerator method on our custom queue class, this will allow the calling code to traverse the elements stored within the custom queue class collection using a for each loop. We'll demonstrate this at an appropriate time during the development of this example. So let's create our delegate type, which will be used to define an event in the custom queue class, i.e. the event that is raised when an item is added to the queue, and also an event raised when an item is returned from the queue. Let's define our generic delegate type directly within the Warehouse Management System API namespace. Let's create a public delegate named queueVentHandler that does not return a value and contains two generic parameters. The first parameter is of type T, and the second parameter is of type U. This is a generic delegate that contains two type parameters. So we must include the placeholder data types within angle brackets. The capital letter T represents a placeholder for the first generic data type parameter, and the capital letter U represents a placeholder for the second generic data type parameter. So now we can define the definition for the event contained within our custom queue user-defined type. So to do this, we use the event keyword. This is a public event to which we want our calling code to subscribe. So we precede the event keyword with the public access modifier. Then we follow the event keyword with the generic delegate type that we have just defined, the generic queueVentHandler delegate. And let's strongly type our generic delegate. Let's pass the custom queue generic user-defined type to the first generic data type parameter, and let's pass the queueVentArgs user-defined type to the second generic data type parameter. Let's name our event custom queue event. So let's implement the code for the onQueueChanged method. This method centralizes the code for raising the custom queue event. So the first argument passed to this event is of the generic user-defined type named custom queue, which is the class in which this method resides. So to get the current object, we can use the this keyword. The second argument is the argument passed to this method's parameter and will contain information about the event and is of type queueVentArgs. So we pass the onQueueChanged method's argument A as the second argument to the custom queue event. So let's implement the code for the addItem method. Firstly, let's write code to add the item passed into the addItem method to the _queue collection. Note that in order to add an item to the built-in C# queue data structure, we must use the enqueue method. So before we write the code to raise our custom queue event, which will be executed every time the relevant queue is changed, let's look at the queue generic collection type in C#. When we use the enqueue method to add an item to a queue data structure in C#, the underlying functionality of the queue collection type is adding the relevant item to the back of the queue, as it were. So later when we write the functionality to retrieve an item from the queue, we'll use the dequeue method. The dequeue method retrieves an item from the front of the queue. The queue data structure works on a FIFO basis. FIFO is an acronym for first in, first out. So the item in the queue that was the first item to be added to the queue when the enqueue method was executed will be the first item to be retrieved from the queue when the dequeue method is executed. We'll use the dequeue method when we implement the functionality for the getItem method. Note that when the dequeue method is executed to retrieve an item from the queue, the first item added to the queue, which will be the item at the front of the queue, is removed from the queue, which means the item that was added to the queue right after the item that was just retrieved from the queue takes the position previously occupied by the item just retrieved from the queue. So the way the ordering of the queue data structure works is just like how a queue works in the real world. For example, consider people queuing to buy tickets to an event. When a person joins the queue, the person joins the queue at the back of the queue. The person at the front of the queue buys a ticket, then leaves the queue, making the person that was behind the person who has just left the queue now the person at the front of the queue. This person can now buy a ticket, and the cycle repeats. So after the enqueue method has been executed, this means the relevant queue has changed, so we want to raise an appropriate event to the calling client code to let the client code know that the relevant queue has changed. When the event is raised, we can pass two arguments to the calling client. The first argument is the queue itself, which is encapsulated in our custom queue generic class. The second argument contains information about the event as well as information about the item that triggered the event. This information is encapsulated in the queue event args user-defined type. So let's write code to instantiate an object of type queue event args. And we want to send information about the item being added to the queue through the message property, which is a member of the queue event args class, to the calling client code. Notice at the moment, if we include a full stop after the item variable, we don't get any properties in the IntelliSense drop-down list in Visual Studio. For example, we don't get the ID, name, or type properties that could provide useful information to the calling client code about the item that triggered the relevant event. So, how can we solve this problem? We can solve this problem by ensuring that items added to the queue implement a specific interface. Then we can add a constraint to our generic custom queue class that enforces a rule that type T must implement the relevant interface. So let's add an interface to our Warehouse Management System API project. Let's name this interface IEntityPrimaryProperties. Let's add three property definitions: ID as integer, name as string, and type as string. Let's go back to the custom queue class, and let's add a constraint to our custom queue class. So we can add the constraint like this: where space t colon IEntityPrimaryProperties. So we now know that any item added to the queue will implement the IEntityPrimaryProperties interface, which means the item will have an ID property, a name property, and a type property. So because we have added this constraint, we should now be able to see these properties if we add a dot at the end of an object passed into the addItem method as an argument. So let's add a dot at the end of the item variable, and you can see the ID, name, and type properties in the IntelliSense drop-down list. This means we can include the information stored in these properties in our message to the calling client code. So in the message property, let's add a timestamp. So I'm going to add a new class named constants so that I can store a string constant that can be reused to represent a datetime format for this project. and let's include the formatting for the relevant date timestamp using our datetime format constant. Followed by the relevant ID, name, and type properties stored for the relevant item. Great, but let's say we want to include additional information in our message to the calling client code. We want to include the quantity of units that make up the item that has entered the warehouse. Remember, items are composed of units. We also want to include the value of each unit with the additional information. For design reasons, we don't want to include the quantity property and the unit value property in the iEntity primary properties interface. So let's add another interface to the Warehouse Management System API project, and let's name this interface iEntity Additional Properties. Let's add two properties to this interface: quantity as int, unit value as decimal. Let's go back to our custom queue class, and let's add another constraint to the custom queue class definition. To do this, we can simply add a comma and then iEntity additional properties to the custom queue class definition. Now let's see if our new properties appear in the IntelliSense dropdown when we add a dot after the item variable, which is of type T. And there you can see our additional properties: quantity and unit value. So let's include the quantity property in our message. The unit value property will be displayed to the user along with all the other properties in a tabular format every time the queue changes. We'll see this when we develop the calling client code. Let's add the following narrative text literal to the message property: has been added to the queue. So let's implement the code for the getItem method. So let's first assign the returned value from the relevant queue, i.e. the value returned from the dequeue method, to a local variable of type T. The dequeue method also removes the item at the front of the queue. So let's write the code that will notify the calling client that the queue has changed. Let's set the message property of the queueEventArgs object in much the same way as we did in the addItem method. The difference is that this method denotes that the relevant item in the queue has been processed, so let's reflect this in our narrative. So let's add the literal text "has been processed" to our narrative. So an item is removed from the queue once the item has been processed. By processed, we mean that the item has been placed in a designated location in the warehouse for storage. The item is added to the queue when it first enters the warehouse. Then the item is scanned. When the item is scanned, the event in the addItem method is raised. When a predefined amount of items are in the queue, the items in the queue are processed, i.e., each item is placed in a specific location in the warehouse to be stored. Each time an item is placed in its location for storage, a pressure pad is activated at the relevant storage location, which raises an event to notify the calling client code that the relevant item has been processed. We have now implemented the code for the custom queue class, and we have also completed the code for the Warehouse Management System API component. Let's implement the code for the calling client. So in this example, we have a warehouse used for storing hardware-related items. When we refer to an item in the context of this example, we mean a collection of a certain type of hardware item. So for example, we are going to use 4 distinct item types: drill, hammer, ladder, and paintbrush. So in this example, an item could refer to a collection of drills, a collection of hammers, a collection of paintbrushes, or a collection of ladders. So let's define an abstract class named hardware item, which must implement the interfaces we created in the Warehouse Management System API component, namely the iEntity primary properties and the iEntity additional properties interfaces. We have already created a reference from the Hardware Warehouse Management System project to the Warehouse Management System API project, but we must also ensure that we have included a directive at the top of our code to the Warehouse Management System API namespace. So let's do this. Great. Let's create auto-implemented properties for each property definition in the iEntity primary properties and the iEntity additional properties interfaces. So let's create classes representing a specific type of item that will be stored in the warehouse. Let's start with the drill. So we must make the drill class inherit from the hardware item abstract class. Let's say we also wish to create more specific properties or behaviors for the drill class. We can do this by adding an interface to define specific properties or behaviors relating to the drill class by creating an interface that the drill class must implement. So let's create an interface named iDrill. For the sake of keeping our example simple, let's just add one property definition for the iDrill interface. Let's make it a string property and name it drill brand name. So this property is only intended to acknowledge that we are able to extend each of the classes representing specific products in this example, but we won't be using these properties further than this. So let's ensure that the drill class implements the iDrill interface. Let's implement the same design for our other items, ladder, paintbrush, and hammer. Great. So let's go to our main method and simulate items entering the warehouse by adding items to a custom queue object. Let's instantiate an object of the generic custom queue class defined in the Warehouse Management System API component that our calling client code references. Let's strongly type our queue with the hardware item abstract class. We do this because all items in our warehouse will inherit from the hardware item abstract class. So the next step is to wire up a method to handle the event defined within the custom queue class. This is an event that is raised whenever the relevant queue changes. For example, an item is added to the queue, denoting a hardware item entering the warehouse, or an item is removed from the queue, denoting that the item has been processed, i.e. the item has been moved to a predefined location within the warehouse for storage. So to wire up the relevant event, we type the object reference custom queue, add a dot, and then we can see the relevant event in the IntelliSense drop-down list. So let's select the event named custom queue event. Then we can type in the += operator to establish a method that we want to execute when the relevant event is raised. So we can auto-generate the relevant method through Visual Studio by pressing the Tab key. We can now implement the custom code we want executed every time the queue changes within the relevant method we have just generated. So let's first write code to clear the screen. So notice that the first argument passed to this method is an object of type custom queue. It is named sender because the event that is fired resides in this class. So the event notification is sent from the custom queue class when the relevant event is fired. So the second argument is of type queue event args and encapsulates relevant information about the relevant event. So let's write code to check if the sender object, which is an object of type custom queue, contains any items. So to do this, we can use an if statement to check the queue length property of the custom queue class. So if the queue length property is greater than 0, let's write the properties of the items stored within the queue to the console screen. Let's create a private method named WriteValuesInQueue to screen that contains a parameter of type custom queue, which is strongly typed with the abstract class hardwareItem. Let's write a for each loop to traverse the items in the queue and write each item's properties to the console screen. So these items will be written to the screen in a tabular format, so I've made sure that each column is set to a specific length. Let's call this method from the custom queue _ custom queue event method, i.e. the event handler method. So let's go to the main method, create 10 hardware items and add them to the custom queue. I'm actually going to change the name of the variable we are using to reference the custom queue object to a more specific name. Let's change the name of this variable from custom queue to hardware item queue. So I've already uploaded the code for this example to GitHub. In the interests of time, let's copy the code that adds hardware item objects to the relevant queue from the code I have already uploaded to a GitHub repository. So let's navigate to this web page from within our browsers and copy the relevant code. And then appropriately paste this code into the main method. So this code, which adds hardware items to the custom queue, simulates items entering the warehouse. To give this example a more real-world feeling, to simulate that these items are entering the warehouse at random times, I'm using the system.threading.thread.sleep method to add a time delay between the lines of code that add items to the queue. So for example, here we are delaying the main thread for 2000 milliseconds, which equates to a 2-second delay. Let's go back to the custom queue _ custom queue event method and add an else part to the top if statement. So if the queue does not contain any items, we want to output status information to the user. Let's output the following text to the user when the queue does not contain any items. Status: all items have been processed. So let's run the code. And you can see that each time an item is added to the queue, an event is raised and our calling client code writes the details of the item to the console screen. Great! So let's create the code for when items in the queue are processed. For the sake of keeping this example simple, let's say that when the queue contains 5 items, we want the items in the queue to be processed. So let's define a constant as an integer, and let's name this constant batch size. Let's set this constant to a value of 5. So we can now write a nested if statement in our custom queue _ custom queue event method that checks if the queue has 5 items in it. If the queue has 5 items in it, we want code to execute that simulates the processing of each of the items in the queue. So let's write a private method named processItems. It contains one parameter of type custom queue that is strongly typed with the hardware item user-defined abstract type. Let's write code to simply traverse the items in the queue through the use of a while loop. The condition of the while loop is that iterations of the loop must continue while the queue is not empty. So we want to dequeue each of the items in the queue, meaning that the item has been processed. Remember that when the getItem method is called, the dequeue method on the underlying queue data structure is called, which means the item at the front of the queue is removed from the queue. Let's add a 3-second delay before each item is removed from the queue to simulate that the item is being processed. Let's go to the custom queue _ custom queue event method and write code to call the process items method. Let's run the code. Now you can see that when the queue is populated with 5 items, the items are processed and each item is removed from the queue once the relevant item has been processed. When the queue is empty, the next 5 items are added to the queue, and once 5 items have entered the queue, the items are processed one by one until the queue is empty. Great! So to further clarify to the user the status of each item in the queue, let's write the message property of the event args object to the console screen. This message property contains a narrative describing the relevant item and the event pertaining to the item. Let's run the code. Excellent! The supervisor can see relevant information about the item as well as the event. The supervisor can see status output for each item as it enters the warehouse and is processed. The final thing to do is enhance the formatting of the output. In the interests of time, let's copy and paste relevant formatting functionality from GitHub. So let's navigate to this location in our browsers. And please feel free to copy my actions here. Let's copy the code situated between the 2 comments that have the text headings. Let's then paste the code into our code editors. We can then write the code to call these output formatting related methods at appropriate points within the custom queue _ custom queue event method. Great, let's run the code. Excellent. So lastly, I'm going to put a few breakpoints in the code to clarify the execution path of the code. So in the calling client code, when the code adds an item to the custom queue, you can see the event that resides in the custom queue class in the Warehouse Management System API component is raised, and the code in the calling client handles the event through a method that was designated to handle the event when the calling client code subscribed to the relevant event. When the predefined batch size of 5 has been reached, i.e., when the custom queue contains 5 items, each item is processed. Once an item has been processed, it is removed from the queue. the event is raised to the client, and the client method that has been designated to handle the event is executed. When the calling client subscribed to the event in the custom queue class, a method that resides in the calling client code was designated to handle the event. When the event is raised, the relevant event handler method is executed. In this event handler method, we are writing status information to the screen so that this information is available to, for example, a supervisor in real time. I hope you have enjoyed this video, which demonstrates the use of the C# generic built-in queue data type, a generic class with constraints, and the use of a generic delegate used to define an event. For more videos on advanced C# concepts and much more, please consider subscribing. And please ring the bell so that you'll be notified of future content released from this channel. If you feel you have gained value from viewing this video, please hit the like button. It will be greatly appreciated. Please feel free to share any of the videos released from this channel with anyone you feel may benefit from their content. Your comments are of course always welcome. The code created in this tutorial can be downloaded from GitHub. Please see a link to the relevant repository below in the description. Thank you and take care.